Okay, now we're going to get into the Arduino code explanation for the esp32 temperature thermistor and its comparison to a multimeter thermocouple. Okay, at the top of the file we have our includes. It's the Arduino.h, wire.h, the Adafruit, and these libraries allow us to communicate with the OLED display, allow communication, and provide the math functions over the for the temperature calculation. Then the OLED setup. Define the screen width, the screen height, and the OLED address, and the Adafruit SSD1306. This defines the OLED display size, the I2C address, and initializes the display object. The hardware constants, right here. Constant int therm_pin34, constant float vref is our 3.3 at our microcontroller, as esp32 operates on 3.3 volt logic. The thermistor is connected to pin 34, and the analog to digital conversion reference voltage is 3.6 volts, and it has analog to digital. It has 12 volt resolution, meaning that the values from 0 to 4095. Our voltage divider values. These values define the voltage divider and the thermistor model. The thermistor is 10K at 25 degrees Celsius, and then the beta constant describes how resistance changes with the temperature. Then we have calibration, our float temp offset minus 1.5. That's how I calibrated the ESP thermistor to the multimeter thermocouple to get 68 and 68. And we have our serial monitor streaming continuously. The averaging function. Here, sum plus equals, or sum, and the analog read pin, the delay of sample delay in milliseconds. This function reads the analog to digital multiple times and then averages the results to reduce noise. The return, this converts the averaged analog to digital value into a voltage. And then, where's the Boolean? The temperature calculation, the Vout reading. Where is that? So Vout. First, the voltage is measured from the thermistor, the current calculation, float current. Using Ohm's law, the current through the resistor is calculated. The resistance calculation, oh my hand, or therm, right here, it's the thermistor resistance, the beta equation, float temp K, it's our beta equation, converts the resistance into a temperature in Kelvin. We have some unit conversion right here. Applying the calibration offset. It's applied to improve accuracy. The OLED display is all right here. Calibrated Fahrenheit temperature is displayed prominently on the OLED, so it's the biggest one. And then we print it to the OLED screen. And then we have a setup function, void setup. Right here. The serial communication, analog to